So these are the crossovers from the Rogers LS6A speakers, which I did a video on earlier, just talking you through the speakers before I took them apart, telling you a bit about them. So we've got an identical crossover from each speaker. I've taken every single component off, or at least lifted up one leg so I can measure them properly for both crossovers. Measured every single component and replaced a couple of capacitors. This one here has been replaced, and I think that one I was able to get some kind of new old stock. My plan was to replace these all with polycaps, but I don't know, I'm more inclined to try and keep these original, and given how well these measure, I'm pretty happy with them, and I think it's probably going to be better to keep them as they are, because they're good bits of kit. So anyway, we've got on the tweeter circuit, we've got a 4 microfarad and an 8 microfarad capacitor, and then a 0.3 millihenry air core inductor. So this is the crossover circuit, if you can see that. So on the tweeter, we come from the positive through a resistor. I've replaced these because the resistors they come with are just sand cast and not particularly great. These will handle a bit more power as well, much nicer resistor, and you can notice the difference. It's just cleaner. That's first in the signal path. So a resistor, which is 1.5 ohm, and then we come through a 4 microfarad cap, which is this one. We carry on to an 8 microfarad cap, which is this one, to the negative of the tweeter. The tweeter's connected out of phase, which is not uncommon. And then between positive and negative, we have an air core inductor. So our high frequencies pass through the capacitors, and any low frequencies left are pulled down to ground. So this is a third order crossover, because you've got the 2 caps and a air core inductor. So a third order on the tweeter, so that's giving us an 8 dB slope. And then on the woofer circuit, we have positive through a 2.1 millihenry inductor, which is this, and then straight across to the positive of the woofer. And then we have an 8 microfarad capacitor down to ground, which is this one. So that's kind of a second order, a 12 dB slope. And then we've got this arrangement here with a capacitor and an inductor. And when you have this arrangement, this will only conduct at a certain frequency. So the idea of this arrangement is to pull a lump in the frequency response. If you've got a humped part that you can't get rid of, you tune the resonance of these 2 components to pull that down. And that's the idea. You could call it a shunt, a notch filter. So yeah, kind of second order with a notch filter. That's what I would describe it as. So yeah, air core inductor, iron core and iron core. On the woofer circuit, not too worried about them. These would be really large if they were air cored. And the long wave lengths, they're not too affected by an iron core. And these are good, they really are good, measure well. So we now have all the capacitors, all the inductors reading as they should do, within 5%. And obviously the same on this. Values are comparable. So yeah, all good. Wiring these come with is nice copper wire. Don't know whether I'm going to worry about replacing it. It's pretty good. So like I say, I'm airing on keeping these original rather than upgrading them too much, because they're a really nice sounding speaker. So yeah, this is the crossover circuit. Like I say, I've measured all the components and sketched this out, so I'm going to do a neat version of this to go with the speakers when I sell them, and written all the values down, so it's there for future reference. So I now need to measure the resistance of the drivers, make sure they're okay, so we'll do that now. Right, so I've got one of the woofers here. I've labelled all the drivers that came out of one speaker and the crossover, labelled them so I know they go back into the same speaker. Right, so we'll measure the impedance of this, or the DC resistance, 8 ohm driver, so we'll just check the meter, let that settle down. So 0.2 of an ohm, so we'll make sure we take that off. So let's, if these leads will reach, I like to keep them short. So 5.4, let's call that 5.1 ohms. So yep, pretty good. It's an 8 ohm impedance, so that's frequency dependent. So as a DC resistance, pretty happy with that. So we'll measure the other one and hopefully we'll get the same results. Okay, so this is the other woofer. Exactly the same specification. So again, we'll just check our meter. Yep, so about 0.2 again. Okay, let's check this. Yep, virtually identical. If we take that 0.2 off, absolutely identical. So that's really, really good. And that's what we want, a matching set of drivers. Okay, so now we'll have a look at the tweeters. Right, so here are the two tweeters. Let's move those up a bit so you can see them. There we go. So these are 6 ohm apparently. So let's see what we get. So you can see there I've labelled A. It goes in cabinet A, and this is B. So I've got some foam down here, so we're not going to damage the metal grill on there. So let's have a look at A. Check our meter again. Yeah, 0.1 again. Okay, let's check this one. I use crocodile clips because you can get a good connection and you can get a stable, undisturbed connection. So let's see. So we've got 4.3, so take that 0.1 off, so 4.2. Remember, these are DC measurements, not AC. So that's A, 4.1 ohms. Okay. Hopefully B will be the same. .4, yeah, 4.3, so pretty good. Within 0.1, they're virtually identical. So, yep, happy with that. All good. So now that the cabinets are all finished, and I've vinyl wrapped them, sprayed the fronts and repaired them so they're nice and solid. We've got some braces inside here. So now that that's all done, we can start to assemble these, get the crossovers back in, and then put the sound deadening back in, and then get the drivers all in. So let's get cracking. So this is all the foam that goes inside. We've got a top and a bottom piece, and this bit wraps around the bottom like that. So this was all loose in there before, so I'm actually just going to put a bit of adhesive in and stick it in place. So for this, I'm just going to use some normal contact adhesive, same thing you'd use for a carpet. Only a little bit, just to hold it in. So let that just go a bit tacky. Doesn't take long. There we go. And then fold it carefully, in it goes. And then inside, try and get it back in like it was. There we go. This bit's a bit more difficult because you've got the base port to get past. Let that go a bit tacky. Okay, try not to get it on the new paintwork. There we go. Okay. Right. Next, we've got the crossover to put back in. So there's 3 studs inside and they just bolt through. So let's do that. So it's important to make sure we get this the right way round. That's the one. There we go. I said earlier when I was talking about the crossovers that a third order crossover gives an 8 dB slope. It doesn't, it's 18. I missed off a 1. So first order tends to give a 6 dB slope, second is 12, third is 18, fourth is 24 approximately. So yeah, before I get pulled up on that. So yeah, the tweeter circuit on this has a third order filter and the woofer second order with a notch filter on the woofer. I haven't worked out what frequency this crosses at. I think it's about 3 kilohertz, but without working it out, I know the values of the components, so I can do that. Anyway. Okay, that's in there, not too tight. So we have our cable for our woofer and our cable for the tweeter, and it's quite important that these are kept off to the side. And then we put this in, which takes a bit of doing. Just scrunch it up, get it in there. Just try and work it in position, get it behind that base port. It's ever so slightly tighter in here now because I've put those battens in to repair the cabinets. So ever so slightly tighter, but it still goes in there pretty nicely. So Again, I'm going to put a little bit of adhesive on this. Not too much. Just let that go off a minute. Okay. Lovely. There we go. And we've got our cable for our tweeter, and we've got our cable for our woofer. Right, so now that's all in, time to put the woofer back on. Okay, so we got the positive and the negative. So we're going to do the positive first. Here's a little trick when you're soldering these in. You don't want to drip solder on the rubber or the cone. So a little bit of cardboard underneath. Be careful not to knock the cable going into the voice coil. I use my soldering iron on quite a low setting. Build up a bit of solder on the end, and then make sure that's on there, hold it in place. Nice bright joint. So that's the positive. And then carefully do the negative. So a bit of cardboard again underneath. Good puddle of solder on the end. Okay, that's the woofer done. So remember to take that out. Cardboard out the way, and then we will carefully drop that back in. Give it a tap. These are lovely woofers, so nice and loose, so smooth, beautiful. So that's in. Right, the tweeter. I'm going to do something a bit different with this. We don't want these crimp connections on there, so we're going to solder those. So we'll cut them off, tin them up, and do the same with the tweeter, and then we can solder them on. Twist these up carefully. This is pretty good copper wire. It's not the biggest copper wire in the world, but it's big enough. So a bit of solder on the end gives you good contact. There we go, nice and tinned. Do the same with this. Got the shakes a bit today, had too much coffee. Not beer, honestly. Right, so they're nicely tinned. So we'll get the tweeter and do that. Right, so I've got my soldering iron on a fairly low setting because I don't want to disturb the soldering for the voice coil. And that can make it a bit difficult to do this. Okay. Right. So brown is our positive. can, I'm going to go in the hole like that and then build up some solder on it. Lovely. And then if we can, same with the negative. There we go. If you tin them up properly, you really shouldn't need to add much solder. They're nicely on there. Okay. Right. So once that's in, we can fix them down. Right. Make sure you get all your screws started first. Don't just put one in and tighten it up and then the next, because chances are the holes won't line up. So while it's all loose, get it all in together. So these have got wood screws on them. The woofer's got inserts, and these are I think M4s that go, maybe not, that go straight into an insert. So get them all started first. There we go. Something to note when you take the woofers out, it's often a good idea when you put them back in to turn them 180 degrees, because sometimes the cone and the bobbin can sort of sag, and if it's rubbing, when you do this gently, if you hear a rubbing, sometimes turning it 180 degrees, so the gravity's pulling it back against the curve it's got going up, can sort that out. So tighten these up opposites, so that one, that one, that one, that one. So we tighten it down evenly and not twist the chassis. Reasonably tight, not too tight. And then once you've finished tightening them down, just gently, evenly push your cone in, make sure there's no rubbing. Perfect. And the same with these. Right, they're all back in and tidy. One thing I like to do, these old screws have got a little bit of surface rust on them, a bit of marking. They're okay, but little trick, Sharpie, black Sharpie. Carefully go round the screw, not the driver. And when that dries and dulls off, those screws look pretty good. Right. There we go. One nice, refurbished, repaired Rogers LS6A. So I've done the grills. They look lovely and new now. They're vinyl wrapped and they're looking pretty smart. The fronts, that's all been sprayed again. The internals, the crossover's been checked over. We've put a couple of new components in, really only where they needed it, because I'm trying to keep these original. Originally I was going to replace all the caps, but they measure so well that I've left them. New resistors and a couple of new caps. Ports are all glued back in. So yeah, I think I'd call these finished. So next video I'll make, we'll get them on stand, get them plugged in and check them out. Okay, thanks very much.